All right, good evening. It is 8 o'clock, so we'll go and get started. All right, so the material for this week focuses on arrays. And so an array in programming languages, and this is not just exclusive to Java, arrays pretty much exist in all programming languages. An array is a way to group variables that are kind of related to each other and that have the same type. Now, when I say they have the same type, remember from throughout the whole course, we have the different types such as integers. We have integers, we have strings, we have floats, and we have doubles, right? Those are pretty much, there's char too, right? Those are kind of like your basic level variables, right? Int just stands for integer. It's a whole number. String is just a string of characters. It can represent words or sentences. A float is a floating point number, like 1.1. A double is a more precise floating point number, meaning you can have bigger and smaller numbers. And then a char stands for character. It's just an individual character, right? But each of these can only store one value. So when we have an integer a, we can give it one value. We just say the value is one. For the string, we could say this is a string, right? That's a single value. For float, maybe we have 1.1. For double, maybe we have 2.2. For character, maybe we have C, right? One single variable. Or one single value, I'm sorry. But that's, all the different, our basic types with how we assign them one value. Well, let's look at just specifically integers, all right? A is one single value, right? But what if we needed multiple integer values? Well, if we needed another one, maybe we call it B. If we need another, maybe we call it C. If we need another, maybe we call it D. So on and so forth, right? But let's imagine, what if we have 10 integers that we need to have in a variable? What if we have 100 integers? What if we have 1,000,000 integers? You can think of like a large database that has a bunch of information in it. And, if we want to get information out of the database, maybe there's 1,000,000 integers that we need to, have a variable for. So do I need to keep going and making integer variables until I get to 1,000,000 of these? Well, no, that's impractical, right? So there's a way that we can make a variable that can hold more than one value, but it has to be the same type. And it looks like this. And we call that an array. And here's what it looks like. You start off with the type. Right now, let's say we want to do it on floats. Let's say we want to have a bunch of float variables. All right. After the float, you put these two brackets, this beginning bracket and close bracket. That means this is an array of floating point numbers. So it's not just going to be one single floating point value, but it will be able to hold multiple floating point values. Next, we give it a name. I'm just going to call it float array. But we're not ready to use it yet. Whenever you have an array, you actually have to do some creation work that will create the array, and you have to specify how big you want it to be. When I say how big you want it to be, you have to explicitly say how many values that you want it to be capable of holding. And it looks like this. We see the array equals new. Again, we put the float, but now inside the brackets, we put how many variables there are. For example, if I put a 64 here, that means this array can hold up to 64 values. You don't have to use all of them, but this is the maximum number that you can use. I could put 1,000,000. That will be 1,000,000 floating point values, and they're all saved into this single named variable called float array. Okay, let's just put this back down to something reasonable. We're just going to say 8 right now. Okay, so that means this array can hold 8 values. Well, what are the values? How do we set the values? You know, if we have float array, we can't just do that. You know, that doesn't work, because this float array, it is an array. It has more than one value. So you have to say which value or which variable in here that you want to make equal to that value. And here's how you do it. You have float array. You again have our brackets, but now inside the bracket, you put which one that you're specifically talking about, which variable in that array that you're referring to. And the way it works, it can start at 0 and go up to a maximum of 7. Now, you may think that may be slightly counterintuitive, but it's really not. And let's look at why. Well, first of all, let me give these different values so that if we print them out, you know, we can see something different. Okay. But that is how we would set the value for each individual variable in this array. Again, the float and the brackets there, I'm just saying it is an array. This is the name of it. That's the name of the variable. And when you make an array, you have to do the equals new, the same type, the brackets, but inside the bracket is how many values you want it to be capable of storing. For me, I'm going to say 8. And now when we want to use each individual value, you access it like this. You have the array name, and then inside of these brackets, you put what we call the index. That's what these numbers are. So this 0 is an index into this array. The 1 is an index. The 2, 3, 4, 5, 6, and 7 are all indexes into the array. And this is just saying what position in this array of 8 floats, which position that I'm referring to. Now, with Java and most programming languages, there are a couple that are different in this regard. But most of the popular programming languages, and especially Java, uses what we call a zero-based index. What that means is when we're counting the variables in this array, we start counting at 0. We don't start counting at 1. We start counting at 0. So when I say this float array with the index of 0, I'm referring to the very first variable in this array. When I have index 1, it's the second variable. This is the third, the fourth, the fifth, the sixth, the seventh, and of course the 8th. That's why whenever we only go up to index 7, even though I said, you know, my array has 8 floats in it, it can contain up to 8. Index 7 is actually the 8th one whenever we start counting at 0, right? So this is all of the variables that I now have access to. And, you know, just like I didn't have to make a brand new variable for each of these 8 values, they're all saved within this one variable name, and you access them with this individual index. So you can make it equal to, you can say the variable equals something, but you can also say something else equals the variable. For example, we could say, so we have another variable down here. It can be something out of our float array. That's perfectly fine. So when we run this code, you know, this creates the array. This sets all the values in the array. And now this set makes a new variable, and it's equal to this value. So what is this value? Well, let's look where we set it. Right here's where we set it. So float array at index 2 is equal to the value 3. So when I say this float another is equal to that index 2 into the array, then this is also now the value 3. So that's how you create an array. That's how you access each individual item in the array. Remember, we start counting at 0. That's the first, that's the first one. I know it's maybe slightly counterintuitive, but that's just the way it works. And 7 is the last one. So if we run this, nothing's going to get printed out, but it will execute. Let's just have something here that says we're done. We are done. So whenever it prints that out, you know the program ran and it executed and it finished, right? So when we run this, see, we are done. So everything worked just fine. You know, nothing happened here. But what happens if we try to access too high of a number? If we put 8 there, what's going to happen? Well, it turns out this variable doesn't exist. Why? Because I said the float array can hold at maximum 8 values. Well, this would be value number 9. This is too big. The 8th index is actually the 9th item, and that's because we start counting at 0. So when I try to do this code, when I try to use an index that's too big, I get a crash. You know, tells me exception, blah, 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 blah. Index 8 is out of bounds for length 8. You know, it's telling me, hey, the length of this is 8, and I'm trying to use index 8, and that's just too big. And then it tells you, you know, specifically the file on what line. It's on main.java, line 12, and you see right here, that's the line that we crashed on. And it's not just one bigger. If I put something a lot bigger and run it, it will still crash because this index 856 is too big because we said there were only 8 of them. Now, I could, if I wanted a lot more, I could change this. Say if I put 1,000 items, now this array can have up to 1,000 variables. Now, is this okay? It actually is okay now. We run it, no crash, and we just get we are done because this is a valid index. And as you can see here, we don't necessarily have to go in sequence. You know, we can put them completely out of sequence. You know, whatever. And that works just fine. There's no requirement to make them sequential. You can access them in any order that you want to access them in. But the key to remember is the index that you're using, it cannot be this size, it cannot be this value or greater. As soon as you make it greater than that or even equal to it, then it's too big of an index. You're using too many variables and you get the crash. All right. So that's what an array is. That's how you make an array. That's how you access an array. And it goes the same for the other types. So instead of float, we could have made an integer array. Of course, now, if we're making an integer array, this over here needs to be new integer. Change that to integer. And that works just fine. Even though it's called float array, you know, the name of the variable is not constrained to, you know, what kind of type it is. Now, you do want to name things, you know, something helpful. So in an actual program or in an assignment, I would probably call this int array or something like that. But the name is not that important. At least Java will not complain about it and it'll work. But this just works just fine with integers. And we see we still get the crash because I still have that high number. If we put 999, it's going to work, right? Because it's not bigger than how many I have. And let's just have another printout down here so we can see what one of the values are. So let's say we want to print one of them. Let's print this one, the float array with index 2. We should get what? The value 3, right? Run it. There you go. We get the value 3. Okay. So again, that's how you make an array. This is how you access it. And then here we're also accessing it to print out the value. Okay, so now why is this useful? Well, it's kind of useful. What I was saying is, if you need to have, if you're reading some strings out of a database, for example, or you're reading a bunch of strings out of a text file, let's say the text file has 1,000 lines of text in it, and you want to, read that into your program. Well, you can't really effectively have 1,000 different string variables, right? Imagine I had string 1 all the way up through string S 1,000, right? That's 1,000 different lines in your program. That's just not practical, right? So you could use it to read strings out of a file and then do some processing on it. You could read some information out of a database and store a bunch of, let's say, maybe there's financial transactions from your bank, right? You could read those into your program and store them in an array. All right. So that's how we create it. That's how we access it. So let's do an example. Our example is going to be, we're going to keep track of what we bought for lunch this week. Okay, so imagine we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and each day we buy lunch at some location and we pay some amount of money. All right, so 2 ways we could do this, right? We could have separate variables. So I could have location Sunday equals Burger King or something. And then we could have the cost for Sunday was $4.56. Whatever. Okay, well, that's Sunday. Well, let's do Monday now. So Sunday, we'll have the location on Monday. Let's say I went back to Burger King. I'm not endorsing them, just thought of it off the top of my head. Then we have the cost of Monday. Maybe we bought the same thing. All right, well, then on Tuesday, we went to Chick-fil-A. And the cost on Tuesday was $6.78, something, right? And we could keep doing this for each day of the week, but that's kind of ineffective, right? Because for all 7 days, each day has 2 variables. There's Sunday, there's Monday, there's Tuesday, but we're going to have to create a total of 14 variables just to hold all that. Well, let's simplify this and just make 2 variables, right? We'll have an array of strings, which call it location, and it will have 7 because there's 7 days in a week, and that's just what we're trying to store. All right. Now we need to have an array for how much we spent, right? We'll say a float array, cost is equal to a new float, also of 7 because there's 7 days in a week. All right. So now let's have the user type in where they ate at and how much it costed. All right. So we can say the location. Actually, we need to make a scanner, right? Make a scanner. System.in. All right. So let's say so the location at index 0, that's the very first location. So let's tell the user to type it in. Out.println, enter location. And then we'll say the scanner dot next line. So that'll get that location. And then let's get the cost. So then we'll say the cost, also at index 0, because it's the first cost, will be a next float. There we go. So that'll get our location and cost for the first day, because we're using index 0, right? And we're saying the location at index 0 is whatever they type in, and the cost at index 0 is whatever they type in. All right, well, that's the first day. Let's do the next day. Let's also tell them what day they're doing. System.out.println, say day. of, was it? This is day one, right? Yeah. Yeah. We'll see what this looks like here in a second once I run it. Yep. So there's day one. Let's just do 3 days so I don't do this excessively. I just copied and pasted. So day one, day two, day three. But now, for the first day, we're using index 0 because it's the very first variable for the location cost. But for day two, we need to use the next one. What is the next one? Is index 1. Index 1. For day three, it'll be the next index, which is index 2. Index 2. Okay. So now we're having the user enter in where they bought food and how much it costs for 3 consecutive days. Let's run it, just make sure it's working like we think. Here we go. Say day one location, Burger King. The cost was $5.67. All right. Day two. Oh, forgot one thing. I know you have ran into this problem doing your assignments. After you enter a number, if you want to do a string next, you have to, get rid of the dummy variable in there and ignore, we'll just say, next. That'll get rid of it. I know you've ran into that issue where you've had your program enter a number variable and then you try to get a string, but it messes up a little bit. That's because of the new line character. You can look that up if you're more interested. Now it'll work properly. All right, enter location. We ate at BK. We spent $5.67. Oh. What am I doing wrong? You'll have to excuse me. Try to see what I'm doing wrong. Well, it's just.
I think it has to be next line, Professor, because it's looking for the new line character when you have next line.
Yep, you're right. Thank you. Well, let's run it. All right, so location, BK 5.56. There we go. Thank you. So for day two, we went to Chick-fil-A and we spent $6.78. Now for day three, we go to Wendy's and we spent $7.89. Okay, and then that's the end of the program, because we're not doing anything else yet. So we're only doing 3 days. Okay, just because I don't want to have to repeat this 7 times. Okay, but here is where I'm putting in the information for each day. Location of 0, that is the first variable, along with the cost of index 0. Then location at index 1, cost at index 1, location at index 2, cost at index 2, and so on and so forth until we get to the last day of the week, which would be, if we were doing the last day, remember, it would be location 6, right? Because since we start counting at 0, if we're doing 7 of these, the last one will be index 6. It's always one less than how large it is. And it has to do with, as I've said repeatedly, we start counting at 0. Okay. So, is this better or worse than having, 14 different variables? Well, right now, it doesn't look like it's too much better because, for each day of the week, I'm having to still repeat all of this code. And I know I've mentioned it in other videos before. I know I've replied to a lot of students that have had questions, and also pointed out some comments in some of your assignments whenever I see this. But whenever you have a bunch of code that kind of repeats itself almost identically, meaning this is almost identical to this, which is almost identical to this, it's a good use case for a loop, to use a loop. So what is the only difference here? The only difference, and this really helps with arrays, is why I'm kind of getting it on this topic, is the only difference is this index, right? Here it's 0, here it's 1. and here it's 2. And of course the cost as well. But that is the only difference between these lines of code, right? So let's see how we can use an array in conjunction with a loop to kind of condense all this down and make the arrays actually much more useful to use. So let's get rid of all this duplicate code. I'm going to get rid of this. Right now, I'm just going to comment this out. When I comment it out, it just means it doesn't execute, right? Okay, so let's make a loop. Let's put some comments in here first, right? We're going to create our arrays. Make a scanner to get input from the keyboard. Now, let's make a loop that will allow us to access all 7 days of the week. We're going to use a for loop. So for int I equals, we'll start at 0, I less than 7, and plus I. My personal preference, I like using plus I there. Most people use I plus, most people use I plus plus. That's valid. You could also use I plus equals 1, a bunch of different things here. But plus I is what I use. All right. So, this is past week things. This shouldn't be new material for you, but this will make a loop that will execute 7 times, right? And just so we can see what's going on, let's print out what I is each time in the loop, right? So what's going to happen here is, we'll make the arrays, we'll make the scanner. We're not using them yet, but that's fine. We're making a little bit of our program at a time, and then we're testing it out. It's really what you should be doing for your assignments as well. But we're going to make this loop where we have this I variable. It starts out at 0. It's going to keep going as long as I is less than 7. And then each time it's going to go up by 1. Let's run this. And you see, we get this counting that goes from 0 to 6, right? Because the first time in the loop, this I is the value 0. That's why we're able to print out a 0. The next time in the loop, I is the value 1. That's why we get the value 1. The next time in the loop, I is the value 2, then 3, then 4, then 5. And then when it gets to 6, I is the value 6, so it's going to print out the 6. But now it's going to say, okay, I goes up by 1, so I is now 7. I look at my comparison, 7 less than 7. Well, that's false. So that's why I skip the loop and go to the stuff after it. So that's why whenever I print out this I, I'm only getting the 0 through the 6. But how does that help us with the array? Well, I said, this array has 7 things in it, has 7 strings in it, and they start off with, location 0. I think that's enough of them. Location 1, 2, 3, 4, 5, 6. That's how I would access each of the locations, right? Well, this access lines up very nicely with what this I value is, right? The first time in the loop, I is the value 0. Well, 0 is the first variable in this location array. The next time in the loop, I is 1. Well, 1 is the next variable in the array, and so on and so forth until we get up to the 6. And that's the last I value we have. So what I'm getting at here is we can move all of this code inside of our loop. So now this loop is still going to execute 7 times, but we need to change it up a little bit to make sure we're accessing the correct variables. So let's look at what we would need to change. Well, first of all, we're going to say day 1. Well, when this executes 7 times, the second time, it's not day 1 anymore, it's day 2. Then it's day 3, then it's day 4, then it's day 5. So we don't always want to print day 1. So what day do we want to print? We say day plus I. We want to do a little bit something different here, but we'll see what it is in a minute whenever we run the program. Actually, let's comment out the rest of this and just run this so far. So we've made this loop. Each time in the loop, it's just going to print out day, whatever I is. When we run it, you can see we get day 0, day 1, day 2, day 3, day 4, day 5, day 6. And so whether you leave it to the I, it depends on if you want to say day 0. In normal counting logic that we use, not programming, we usually start counting at 1. We'll say day 1, day 2, etc., etc. But the I in our programming language, we start counting at 0. So it's really, I guess, your preference for your output if you want to start with day 0 or you want to start with day 1. I'm going to use day 1 just because that's a little bit more natural for a user. So we'll just say I plus 1. That means, the first time in the loop, I is 0. So I'm going to print out day 0 plus 1 will give me 1. All right. So the first time, this will give me day 1. The next time in the loop, I will be the value 1. So then we'll say, okay, 1 plus 1 is 2. So it'll print out day 2. Let's run it and see what it does. And there you go. That's a little bit more natural for a normal user to be showing, day 1, day 2. Day 0 is maybe a little unnatural for, just an end user of the program who may not know anything about programming. So that's why I like to do my display like this, because it's a little bit more natural for the user. Okay, so now let's get the rest of the input. All right, so we're going to say whatever day. Now we're going to just print out enter the location, nothing to change there. Here we're getting the location. We do need to change something here, and I'll mention it in a minute. Then we again print out enter the cost, and then we get the cost like this. We also need to change this one. So what is the change we need to make? It has to do with the index right here. So our loop is going to execute 7 times. But if we leave the 0 here, then every single time it's just going to put it into the first variable. And actually, let's make another loop down here that will print out all of our information, just so we can see what is actually in that array. So we'll print out, we'll print out the location, and we'll print out the cost. Right. That's a little bit of a sneak peek. We'll talk about this in a minute. But for right now, just ignore that, but just know that'll print out all of the information in our variables. Actually, let's print out the I too, so we know which one it's doing. All right, there we go. So let me comment this out again. And so what we'll see here is, what it's actually printing out. So I've created the arrays. I've made a scanner doing a loop 7 times. I'm printing out the day. I'm not putting anything in those variables yet. It's commented out, but I want to print it all out. So let's see what happens, and then we'll slowly add more to our program. We run it. There you go. What's getting printed is this print right here. So when I is 0, null, that's just the way to saying that the string doesn't have any value. So when I'm saying this location, it doesn't have any value. There's nothing in the string. And then the cost is 0. And you see that gets repeated 7 times. So that's showing us everything in our array. Okay, that works. So now let's get the information in there. All right. So imagine we didn't know what to do with this. And I've told you this index 0 is incorrect. But if we just left it, we made a mistake. Let's see what happens. So when I run my program, so day 1, enter location, BK 1.23. Day 2, I'm just making up letters now. QW 2.34. Day 3, ER 4.56. I should have used less days so it didn't take as long. 7.77, fine. Day 6 is the last, actually day 6 is the next to last day. And then day 7, the last day, we go to this place and pay 9.99. All right. So now when we print everything out, only the first variable, only the first thing in our array actually has values. The rest of the array is still blank, right? A blank cost and a blank screen, a blank string. But the one at 0 has the correct information, or it has the last information I put in, right? The last information I put in was eat at that location for that cost. And you see it's saved there. So even though I put in all this other information, why did it not go into these other variables? Why is it not displayed here? And the reason is precisely what I was talking about with this index. Because each time in the loop, I said, okay, location at index 0 is whatever you type in. The cost at index 0 is whatever you type in. And so every time, even though I'm displaying different days, I'm still only saving it into that index 0 variable. So how do we make it go into the next one and the next one and the next one? Well, that's really easy because we already have this I that is counting from 0 up to 6. So if we change the index to be I, it will work out nicely. And why is that? Okay, the first time in the loop, I is 0. So this will display day 1, right? Because I is 0. Now we're going to say the location at index I, but I is 0. So location at 0 is whatever we type in. Cost at 0 is whatever we type in. Okay, next time in the loop, I is the value 1. Okay, so now we print out day 2 because I is 1. So now location at index I, but now I is 1. Last time it was 0. This time it's 1. Next time it's going to be 2. The next time it's going to be 3. So on and so forth. So now I'm saying the location at 1 is whatever I type in. The cost at 1 is whatever I type in. The next time through the loop, I is 2. So the location at 2. So on and so forth. So now let's run this. And you'll see whenever we print out our array now, all the values will be filled. Let's run it. Location, AA, 1.11, DB, 2.22, CC, 3.33, DD, 4.44, EE, 5.55, 6, GG. I lost track of my numbers. That's fine. 7. There we go. So now when I print them all out, the entire array is filled out properly because this is the first thing I typed in, right? AA at 1.11. Yep, that was my first day. My second day was BB 2.22. Yep, that's correct. And all through all of them up until the last one was HH at 6.78. And that's what the last one is. So now I've been able to use this loop to get all of the input I needed for my variables. So now I no longer have the 14 variables. You know, I didn't have to have 14 variables. I have 2 variables, and each one of them has 7 values. Now I've used a loop that will loop 7 times, and each time it stores it, whatever you input, it saves it into that location at I, where I goes up from 0 to 1 to 2 to 3, 4, 5, and 6. Right. So that's how you kind of combine an array with a loop to get some useful information. The last part of this example we'll show, and we'll kind of wrap it up and see if you have any questions, is, okay, so we have the values in there. What else can we do with it? Well, having variables in array is a easy way to make some kind of computations, right? Let's say we want to compute how much money did we spend the entire week. A couple different ways we could do it. We could do, make total cost equals to the cost at 0 plus the cost at 1 plus the cost at 2. Bear with me a second. Oops. Cost, if I can spell, 4 plus the cost, 5 plus the cost as 6. And that would work. Let's just print it out. Got print ln. Let's just say that we'll just print out the total cost. We'll take out this print statement. We don't really need it anymore. We kind of saw that it does save it correctly. So we did this math. We input everywhere we ate, and this is going to compute the total cost. All right. One change we're going to make, I'm going to make this 3 instead of 7, just so I don't have to keep typing in and wasting time doing that many of them. So now we're only going to get 3 days of input, and that's fine. Maybe I only want it for the last 3 days. Okay, so the cost will go from 0 up until 2 now, right? I'm just cutting out excess typing. Oops, there we go. So I could compute the total cost like this. Let's run it and see. Well, that does actually work. Oops, got this too far. There we go. So let's run it. So say AA for 1.11, BB for 2.22, and CC for 3.33. Total cost was 6.66. And that's right, because if we add up each individual day, that's the total it comes to. Okay. Well, that was pretty easy to just type like that, right? Okay, well, imagine you want to compute it for the past year, for the past 365 days. Just like with the other example earlier, we were doing a bunch of repetitive code. We would have to do a bunch of repetitive code here, right? Cost of 3 plus the cost of 4 plus the cost all the way up to 364. Oops, right? We would have to repeat this over and over and over until I do that. And that's going to take a lot of typing, a high probability of errors if you're having to do all of the numbers between 0 and 364. So instead of doing that, let's use another loop to add up all of the costs. So we'll say the total cost will start at 0. Let's make another loop. Less than 3 plus I. And the reason why I'm using 3 now is because my array is only the size of 3. I'm only entering 3 days worth of information. And so I want to add up 3 days of costs. So this total cost can start at 0, but now we will add to it the cost at I. And what's happening here? So total cost is 0. All right, we have a loop. I starts out at 0. So whatever the total cost is, we will add the cost at index 0. The next time in the loop, I is 1. Okay, so now we're going to add in the cost at index 1. Next time in the loop, it's 2. We'll add the cost at index 2. So you see, this is a whole lot easier. So even if we were doing a full year, I could just put 364 there, and now that's going to compute the total cost for the past 364 days. If I only wanted 7 days, I just put the 7 there. Now, granted, when you have that, you also have to actually input the extra information. You have to make the array that size, meaning this would have to be 365 days. This would have to be 365 days. I'd have to put in 365 days of information, and then I could compute the 365 days. It's not very realistic for me to input that much information right now during the class. Let's just say we'll do a week. So change all these to 7. I was able to change, how big the array is, how much we're inputting, and how much we're computing just by changing this number. I'm not having to put plus more costs just by changing how many times the loop does. Let's run this, and you'll see we get the right answer. So QQ at 1.11. Oops. We just put in a bunch of dummy locations and dummy costs. Six. And then the last one. And there I've got the cost. This is how much money I spent this week kind of on food. Well, for lunch, right? Okay, so that is really about all there is to arrays. Arrays can be really used for so many things, and they'll be used in pretty much every program that you ever interact with. But one last quick summary. We're making an array. It's going to hold string values. So string with the brackets means it's an array of strings. This is the name of the variable. And to create it, because we have to create an array, because we have to specify how big it is. So it will equal a new string with the brackets, and inside there is the maximum number of items that it can contain. And then the same thing for this cost. Here, the example we just made, scanner. Now we're going to make a loop. It's going to loop 7 times. But since we count at 0, it goes 0, 1, 2, 3, 4, 5, 6. Each time in the loop, the location at index I is equal to whatever we type in. So the first time I is 0. The next time I is 1. The next time I is 2, so on and so forth. So that's how we input information into the array. And then here at the end, we're just doing a simple computation. We're saying, hey, look, what's the total cost? So we can make another array. Again, we will loop 7 times because that's how much information we have in the array. And we just keep track of the total cost by adding the cost each time. So the first time, this will be cost at index 0. The next time, it'll be cost at index 1, and cost at index 2, so on and so forth until I get all the costs. And then we print it out at the end. All right. So that's all there is to arrays. And so for your assignment, it's really not that much different than kind of what we did here. So, for our example, we're putting in where we ate for lunch and how much we spent, right? But for your assignment, you're doing like a robotics competition where you have to input the name of the team and you have to input what their score is. But their score needs to be an integer. I'm using floats here, but you should probably use an integer for their score. So that's how you input all the information. And then I know you need to go in there, you need to figure out who has the highest score and who has the lowest score, right? Well, you would still use the same kind of loop, except you need to figure out, okay, well, how do I find which of these scores is the highest? How do I find which of these scores is the lowest? And that's kind of the exercise I will leave to you. If you struggle with it and you have problems, you can email me and ask for assistance, and I can kind of give you hints. But I think it's a good exercise for what you should try to figure out how to do on your own. So that's it for this week's material. I will take any questions you may have.
I have a question, Professor, a couple of them actually.
Okay.
One related to the assignment is I wanted to make sure that we could expect all these scores to be of different values, meaning when we find the min and max, we don't have to worry about identical values.
If there are identical values, you can just say any of them would be correct, I guess is the best way to say it, or the first one that is the highest. Does that make sense what I'm saying?
Yeah. So you wouldn't expect us to report a tie necessarily.
Yeah. Yeah, if there's a tie, you can just report one of them and that would be acceptable.
Okay. And the second question is just related to, excuse me, why do you prefer to use the plus plus I as opposed to I plus plus?
Uh, okay, so the plus plus I, this is way, way, way beyond the scope of this class, but it's an interesting answer if you are interested in it. So I'll go over it. Okay, so the way things work kind of behind the scenes is how long does it take for the computer to execute something? How long does it take the computer to do something? That's an important question to ask when you're dealing with, 10 million of these loops, maybe, right? Maybe you're looping over every person in the US, and there's like 350-ish million people in the US. So let's maybe have a loop that does 350 million times. That's a lot of times. And so you need to take into consideration how long it takes for pieces of code to execute, because the faster it executes, the faster your program is, the faster you'll do the computations and so on and so forth. It turns out that plus plus variable is slightly faster than variable plus plus. And it has to do with in the background of the machine, this actually makes a copy of the variable. It adds one to that variable, and then it copies it back. So there's two copies of data happening there. When you do it this way, it really does just increase it by a value, and it increases the value by one. There's none of that copying going on in the background of the machine. Since this I is just an integer, it is extremely negligible, that difference. But you can have a lot more complicated loops to where this may not be a simple integer. It may be something much more complex. And so if it's more complex and you're doing multiple copies of it, it will take a lot longer for your loop to execute. So this makes copies of variables. This does not make copies, and so it just runs slightly faster. So
Got it.
that's the reason I prefer the plus plus. Again, for an integer, it's negligible. You'll probably never measure the difference. But if this was something more complex, you would tell a difference.
Now we train as we fight, right?
Yep. All right, if there are no further questions, we'll go ahead and wrap it up. Like again, if there's any issue with any of this material you have problems with, or you ask questions or assistance for assignment, please just email me. I'm usually can get back within an hour or two. Email is the most preferred method. I get instant notifications of those. But that's all. Everyone have a good rest of your evening.
Thank you. Good night.